All right. I wanted to touch on a couple of items that don't necessarily fit into any one area. So sorry that these don't all necessarily coincide with each other. But we're going to start out with piecewise functions. Piecewise functions are just a way of saying that we're going to change the function dynamically based on some criteria. So most of the time you're going to see it's going to be defined as a domain. So when x is less than 0, we're going to use this function. When we go from at 0 but less than 6, we're going to use this one. When we are greater than or equal to 6, we're going to use this function. So if they're asking you what is the behavior of f of x at x is negative 1, we would be using the x plus 2 function, and we could ignore these other two. That's the idea. And they make some kind of peculiar graphs. I'll show you what this one ends up looking like. But we can see, right? So for x being anything less than 0, this is the behavior of this function. And then as soon as we hit 0, or right beforehand actually, it's less than 0, when we hit 0, we move to the 3x minus 5 function. And again, we move up, and as soon as we get to right before 6, and that's why it says undefined there, because it's less than 6, we're going to jump to the blue function, which is 6. X is greater than or equal to 6. So on these functions, on the practice, when you get one, you're gonna see one. Just realize that they're asking for the behavior in that range or that domain, whatever it may be, and you can ignore all the others when doing that, unless it falls in between like 2 or something. For the next piece, we're going to talk about inequalities. So again, like inequalities don't fit perfectly in any little box because you could have an inequality with anything. For the most part, you can treat them the same as equalities, but solving them, note that multiplying or dividing by -1 will switch the sign. So for example, if we take -2x is less than 4 and solve for x by dividing by -2 on both sides, what we get is not x greater than -2. Oh, I'm sorry, we do. We get x is greater than -2, not x is less than -2. So if you notice, less than was changed to greater than when we multiplied or divided by a negative number. And I mean, we can put like real numbers with this so you can understand more intuitively. 3 is greater than -2. If we multiply both sides by -1, which is a legal operation, if we kept that sign the same, what we would get is -3 is greater than -2, which is incorrect. So we have to switch the sign when we do something like that. Moving on to the next piece. On another note, we can realize that inequalities may be used on the praxis to define areas or domains and ranges. So in the picture below, we have two functions, and the x squared minus 2x plus 1 is this green one right here, and it has all of this area defined. The 2x plus 1 is the pink area and has all area below it defined, right? Less than. They may ask you where they overlap, and actually this could be a perfect like transition for them to go into area between two curves using an integral or something along those lines. So what that looks like, if we're going to have it be more like dynamic, so we have a quadratic in purple and a linear in pink, and for the linear it's y is less than, and in the quadratic it's y is greater than. And if we play around with these values, you can see that the area where they overlap changes. But the actual shape of the function doesn't really change, right? So if we took this and we created a function with an equality, we see that it outlines it perfectly, right? So for the most part, it's doing the same thing. It's just saying that this range in this domain is included in it as well. And that should do it for this one.